All right, let's do this example together. Question 4. So I got a random sample of people. They're tested for this virus. It said that 221 did not have the virus. Let's first find this confidence interval. Okay, so the confidence interval of those who do not have the virus. So I got N is 270 people total. P hat is the number of successes, those who do not have the virus. 221 over 270. Okay. I'm gonna fix my N there. So the first question says, what am I estimating? Well, for sure, I'm not estimating p hat because I know what that is. And so the picture we have is our population. We take our sample, and the sample is where we get this information from over here. So what we don't know is the proportion of the population. So we use the variable p for that. So that'll tell us what we're estimating. These other parameters are things we might use in the future, but really p is what we don't know. That's what we're trying to estimate. The point estimate is always called p hat, and that's that value of 221 over 270. So this is question 4. 1 divided by 270. So I will just copy paste that in there. That's my point estimate. So now let's check our conditions. It says check all the conditions that are satisfied. So we would say n times p. Actually, I got to say that this is p here. Let's call that p. Well, really it's p hat. And n is 270. I'm going to run that. And n times p would be the number of successes. N times 1 minus p would be the number of failures. So it looks like the successes are really 270 successes and failures. So that's met. These have to be greater than 10. So we want to know that the t distribution is, well, nearly normal since these are greater than 10. P is successes, Q is the failures. And we also need to know that we're sampling randomly to ensure independence between our individual people we're sampling. So those are the conditions for this test proportion. And now let's find our margin of error. Remember, as from before, the margin of error, I'm going to erase my work here. The margin error is my Z star times the SE. Let's first find our Z star. Z star comes from the confidence interval that we want to find. So we're looking in this problem at a 99% confidence interval. That means alpha is 0.01. That's our significance. I'll say Q norm of 1 minus that divided by 2 to account for the two tails. So that's my Z value. So I'm going to multiply that times my SE, which I don't have yet. The SE you can copy from before. That's my SE. And as long as I enter P and N correctly up here, they're good. Well, notice I didn't use P here. So I should actually say P like that. Yeah, there we go. So now that my SE is good, you can check that. My standard error will be how many standard deviations I go to the right. So 2.58 about. So that's my margin of error. Whoops, not that. That value. And then the confidence interval is just p hat plus that and p hat minus that. So p plus that and p minus that. So I can use my confidence interval in this answer, which it says to use decimals, not percentages. Okay. And it says to use the lower one first. So I'm going to take this lower one, say parentheses lower, comma, and then that upper one. If you haven't flipped it, we'll be like, what are you talking about? So that's my confidence interval. That means with 99% confidence, the true and underlying population proportion lies between these two values. So let's see which one of these gives the correct conclusion. Where 99% of the 99% confident the portion of the sample are tested have the norovirus. Well, we don't need to use a confidence interval for the sample. We know what's going on in the sample. We know exactly, what is it? 81%. So that wouldn't make sense. We're not talking about the sample with our confidence interval. So both these mention the sample. We're actually talking about the population. That's the purpose of constructing our confidence interval. So what are we looking at? 99% confident the proportion of people have the norovirus or do not have the norovirus, the norcovirus. So looks like we're counting the number of people who did not have it. So we got to be consistent in how we interpret that. We're going to look at those who did not have it. And I'll check my work. Everything looks good. All right. See you on the flip side.